Hello folks, we are once again back with this exercise 7.6. Now we are into the 13th problem, which says that it is integral of tan inverse x dx. Now it's very clear to us that the function, there is only a single function, so it may not be so convenient for us to work with this single function tan inverse x. So probably we can make a substitution, and that way we can start doing our work. So right away, let's call t as tan inverse x. Then in that case, we know that the derivative, that is, or otherwise, therefore this will become x will become tan t. So dx will become sec squared t dt. Now let's see how we can convert our integral. So our integral will become tan inverse x, which is t, and this dx can become sec squared t dt. As a result, our integral reduces to t sec squared t dt. Now this, we need not be doing the integral once again, because as I have written on the top of the board, integral of x sec squared x dx we have already done in the exercise in the problem number 12. That is just the previous problem, we have done that. So whatever integral we get there, that itself we can write over here. So that will help us to get the integral easily. So directly we can write, since we have done just in the previous problem, but that will not happen in the exam. In the exam you have to derive it once again and show. But here, since we have just done it in the previous problem, we can take the result and write it there. So therefore that result says that it is x tan x, which is here t tan t, and log minus log sec t over here plus c. Now t is your creation, so as usual we have to revert back. T for us is tan inverse x, and tan t for us is x, so x tan inverse x minus log sec t. Now it's very clear, from here we can get the conversion that sec t is always root of 1 plus tan squared by the identity we know. So therefore it is going to be root of 1 plus x squared. So it's going to be root of 1 plus x squared plus c. We don't keep it in t because t is your creation. Now this half and all, you can take it as an exponent. So log we have our own ways of doing it. Log raised to half, so half can come as an as a coefficient here. Maybe you can do that. So you could write this as x tan inverse x minus half times log modulus no root, because we have taken the half, log modulus 1 plus x squared plus c if you want. That is the way you could do the conversion. I'll quickly just do the cross checking before we go to the next problem. That's it. So that's because we applied the result directly, we did not have to write much, and so we could wind it up over here. As a result, we could take the 14th problem, and let's see what the 14th problem says. 14th problem says that it is integral of x log x the whole square. X is to the exponent 1, but log x is the whole square dx. Now as we always do, we will apply our isolate. So it's very clear to us that x for us is algebraic function, and this is the log function, and we have the isolate which says that log comes first. So let's apply the u and v and all that. U for us is log x the whole square, and v for us is x. We generally find out du over dx. So that's the derivative of log x the whole square. So first we have to find the derivative of the exponent and then the derivative of the base. So like that, it is going to be 2 log x, and derivative of log x is 1 over x. So that's our du over dx. Let's find out integral v dx. So that's going to be x squared over 2. Now let's write the I we know by formula, u integral v dx minus du over dx integral v dx the whole dx. And that way u for us is log x the whole square, v dx we have got it as x squared over 2, and du over dx, what is that? It is 2 log x over x, and then integral v dx is x squared over 2. Oh, so many things that get cancelled here. The 2 can get cancelled, the x can get cancelled. So we are getting, maybe you could write this as x log x the whole square, or write it separately, that's one's own convenience, over 2 minus, this is going to be integral of x log x dx. Now integral of x log x also is something that we have already done in the exercise in the problem number 4. So there, that also we will be applying directly because it's already done in the exercise at the problem number 4. And the integral is like this. It's x squared log modulus x over 2 minus x squared over 4 plus c. So let's apply that. It comes to x squared log x the whole squared over 2 minus, we are applying the integral, and the integral is x squared log modulus x over 2 minus x squared over 4 plus c. See, so you could open up the bracket, and so maybe when we modify the answer, it could be x squared log x the whole square. You could write it as log modulus x also, and then minus x squared log modulus x over 2 plus x squared over 4, because we are opening the bracket, plus c. So that's going to be our integral after we apply, where we open the bracket and we do it. Those two results, since it's already done in the exercise, we are using that and applying it over here rather than doing it all over again, but that will not happen in the exam. We have to show it, show this result, and then only apply it in the problem. So that should be all for this video. So with more problems, we'll be meeting in the next video, and as always tell, please popularize the channel, spread a word, and see that we get a lot of subscribers, and the channel becomes very popular. Thank you.